Hello and welcome to today's lesson on chemical bonding. So we're going to start with our introduction. We're going to get into writing and naming chemical formulas in this unit. And so we're going to start with the basics today. We're going to writing and naming ionic compounds and covalent compounds as we progress through. But today's kind of the basics, so the information you need in order to be able to write and name those compounds. So let's get started. Objectives. You're going to describe the differences between these ionic and covalent bonds. You'll be able to determine what type of bond is formed based on that property of electronegativity, which we talked about in the last unit. And then we're going to talk about both polar and non-polar covalent bonds. You'll be able to tell me what differences are taking place between those. So first, a quick vocab review. It's important that we know some different terms. So the first one's cation. Remember, cations are atoms with a positive charge. You draw your cat face. You can put a plus sign as the nose. That was really bad. But cats have a plus sign for the nose. Cats are positive. However you want to remember that. Anions are atoms with a negative charge. Remember, ants have a negative sign. They make you negative when they bite you. A polyatomic ion. So poly means many. Atomic refers to atoms. And ion is an atom with a charge. So many atoms carrying a charge is your polyatomic ion. And then valence number, or oxidation state. This is the number of electrons that need to be gained or lost in order to fill the outer shell. And so this is what we're going to use a lot of today. And in this unit is oxidation state or valence numbers, however you want to word that. And the last one is octet rule. And this is the idea that atoms want to have 8 electrons in their outer shell. That is all atoms except for hydrogen and helium. They want 2. So those are your vocab terms we need for this lesson here. So let's get started. We're going to talk Lewis dot structures. So when we draw Lewis dot structures, we're looking at what do those tell us about an atom. And in this case, Lewis dot structures tell us the number of valence electrons. And so if I'm drawing Lewis dot diagrams for sodium, I'm going to find sodium on the periodic table. It's in the top. It's on the left side, column 1. Everything here has 1 valence electron, so sodium has 1 dot. Phosphorus is in column 15, which means it's got 5 valence electrons. So I'm going to go 1, 2, 3, 4, and 5. I'll let you do the last 4. As make sure you put dots for the number of valence electrons. Remember, they cannot, you can't double up occupancy until you have each room has 1 electron. But finish these last 4. And then hit the play button and we'll continue on. Here are some more Lewis dot structures. So atoms versus ions. So if I'm drawing a Lewis dot structure for a potassium atom, I'm going to have K here, and it's got 1 valence electron, which is found right there. If I'm looking at a potassium ion, we're going to put ions in brackets just to make sure we're there. But I'm going to put K, and because I lost this 1 electron, potassium is going to lose that 1. It's going to have a positive sign. So oxygen is going to be here. It's going to have 1, 2. And on this side, oxygen is going to have none. So it's going to lose 2. It's going to be negative 2. So I'll let you try these last 2 on your own. And then again, hit the play button and continue on. So really quick, what do Lewis dot diagrams tell us about an atom? And then draw an electron dot diagram for a fluorine atom and a fluoride ion. So make sure you can do that. Pause the video if you need to, and then when you hit play, we'll continue on again. So now there are 2 main types of chemical bonds that we're going to worry about in this class. The first one is going to be ionic, and the second one is going to be covalent. There are a couple other types of bonding. We have metallic bonding, we have hydrogen bonding, but those we're not going to focus on as much as these 2 because this is going to be the important part of this course. So we could have hydrogen, we could have metallic. And we'll reference hydrogen bonding a little bit, and even metallic bonding a little bit, but we're going to focus on this ionic and covalent systems. To compare ionic and covalent, we have some differences. So 1, ionic bonds are formed from electron transfer. So atoms lose or gain valence electrons, whereas covalent bonds are formed by sharing valence electrons. So ionic gains and loses, covalent shares. In the case of an ionic bond, we have cations and anions. We have positives and negatives coming together. And the positive tends to be a metal, is a metal, and the negative comes from a nonmetal. Because metals, remember, have between 1 and 4 valence electrons, so it's easier to go from that to 0 than it is to go from that to 8. Nonmetals have more than 4, so they have 5 to 8 valence electrons. It's easier to gain and get to 8 than it is to lose more than that to get to 0. In the case of covalent bonds, we have a nonmetal bonding to a nonmetal. And then, as far as terminology goes, ionic bonds form what are known as ionic compounds. And that is just how we reference them. And then covalent bonds form what we call molecules or molecular compounds. So ionic compounds are ionic bonds. Molecular compounds are covalent bonds. Sometimes they cut out the ionic part and they just write compounds for ionic. It's kind of a nightmare. But typically compounds refer to ionic bonds. Molecules refer to covalent bonds. If you see this word molecular, think molecule. So that would be covalent. In regards to covalent bonds themselves, we have two types. One is called a polar covalent bond. In a polar covalent bond, we have electrons. So think of poles like the Earth has a north pole and a south pole. These are on opposite sides, and they're different. So just like that, in a polar covalent bond, we have electrons being shared unequally. So we're going to have an atom, or a molecule, I guess, that has a slightly positive charge and a slightly negative charge. That was a really terrible drawing. Let's look at this. So this is an example of water, which is also shown here. So hydrogen is going to have a slightly positive charge, and oxygen is going to have a slightly negative charge. Because oxygen wants to have the electrons more than hydrogen does, it's going to hog them, and it's going to create a slight negative charge, which leaves hydrogen with a slight positive charge. So it's got a little bit of a charge there, even though water itself is stable and considered neutral. Nonpolar bonds don't have this difference. These are like, think of twins that share things equally, twins that get along and share things equally. What's yours is mine, what's mine is yours, everybody's happy. So nonpolar bonds are shared equally, and so because the electrons are dispersed evenly, the charges stay the same, and it's all there. And then begs the question, what causes different bonds? What causes some to be ionic and some to be covalent? And in this case, we're looking at properties. So which property of atoms that we learned last unit determines the type of bond between atoms? And so we look at this, we're looking for electronegativity. And this is how tightly it bonds to electrons from other atoms. And so if we look at the electronegativity difference between molecules, we can determine what type of bond is formed. If the difference between two molecules is between 0.0 and 0.3, it'll be a nonpolar covalent bond. In the case of fluorine, fluorine has an electronegativity of 3.98. And so if I take this fluorine minus this fluorine, I get 0, which makes it nonpolar. If it's polar, it's somewhere between 0.3 and 1.7. So I have carbon and oxygen. So carbon has an electronegativity of 2.55, and oxygen has an electronegativity of 3.44. Because this is going to be less than 0, we're going to do absolute value bars. And so if I take 2.55 minus 3.44, I'm going to get negative 0.89. I can drop the negative because we're doing absolute value, so it's just 0.89 is there, which falls in between 0.3 and 1.7. So carbon and oxygen form a slightly polar molecule. And then if the difference is greater than 1.7, so for example, potassium and chlorine. So potassium is 0.82, and chlorine is 3.16. So again, we're going to get a negative here, so let's do absolute value bars. If I subtract those two and take the absolute value, I get 2.34 as my difference, which means that's going to be an ionic bond. So here are some for you to try. Go ahead and pause this video and work through these. I have answers on the next slides. When you hit play, you're going to get your answers. And here they are. So these are your answers for those calculations. If you have questions on them, please come see me, and we will kind of work through it. I'll help you out, and we'll figure out where we're miscommunicating at and missing at. So some last little notes. Some characteristics of these bonds. So ionic bonds tend to form crystals, and they're hard and brittle. And because they're crystals, that means they're solids. Covalent bonds form all states of matter. They can be solids, they can be liquids, they can be gases. Ionic bonds typically have high melting points and high boiling points, whereas covalent bonds have low melting points and low boiling points. Covalent tends to be more flammable. They react with oxygen more readily. Ionic bonds are highly soluble in water, meaning they can dissolve in water. So think of Kool-Aid, or think of salt water. More importantly, salt water, not Kool-Aid. But because salt is highly soluble, salt is ionic as well, so it dissolves readily in water. Covalent bonds, it depends on the type of covalent bond and the substances specifically. So oil does not dissolve in water, but sugar does. So Kool-Aid would be an example of a covalent bond. Sugar molecule dissolved in water. Oil and water do not mix at all. And then ionic bonds form what we call electrolytes. So electrolytes are substances that can conduct an electrical current when dissolved or melted in water. And so electrolytes are formed from ionic compounds, strong acids, strong bases, and weak acids. Covalent bonds do not form electrolytes. They do not conduct electricity through them when dissolved in water. But covalent bonds do form what we call diatomic molecules. So diatomic, dia meaning two, or di meaning two, di meaning two, atomic referring to atoms, so two atoms bonded together. So in nature, we have bromine, we have iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine are all diatomic molecules when they're found by themselves. I collectively call these the Brinkelhoffs. And so if you can remember Brinkelhoff, all of these, when found by themselves, have to be written with a little subscript 2 to show there's two of them. Rarely, super rarely, do you find a single oxygen atom in nature. It's going to bond to something, including itself. So you're always going to find O2. All right. Here's some fast review questions. Look through these, answer these. If you have questions, please come see me when you return to school or shoot me an email. I look forward to working with you through the rest of this unit. Enjoy the rest of your day, and I will see you later.